Very good evening again. So this is the end of July 2023, 30th of July. Okay, so we like to welcome you to take part in our airport session, Astronomy Picture of the Day by NASA. Remember, airport started in 1995. I've been following airport since 1995. So again, we are very fortunate to have here our presenters. I'm Dr. Chong, okay, from the Astro Society of Penang, and our Miss Chiu Boon Wei there, and our Gu Yun Ning also. So three of us will be presenting our pictures. All right. So first of all, I'd like to thank also our Michael Chiu, our ASP member who is hosting this event, and also our Mr. Lai who selected the pictures lah. Okay. So now we go to the first what you call picture. I will share the screen now. Wait a minute. Okay. Can see Boon Wei? Boon Wei, can you see now?
Yeah, I can see.
Okay.
Yes.
So now, July the 30th, 2023, spiral aurora over Icelandic divide. Now, ladies and gentlemen, we have to be prepared that in the years to come, 2023, 2024, 2025, where the sun is getting more and more active, you'll see a lot of pictures on airport on aurora. So I'll read out first, then I will swing the picture. So this is spiral aurora over Icelandic divide in Iceland by our Juan Carlos Casado, an amateur astronomer from Spain who went to Iceland to do it. And he's in this astrophotography group called Starry Earth. And of course, Tuan. Tuan is a famous, the world at night, famous one, okay? Astrophotography group. So basically, you see here, I'll swing now. Boon Wei saw, wow, what is the first thing that came to mind? What is this hockey stick doing in the sky like a hockey stick? Okay, so basically, it's an aurora. The green look like a hockey stick, and the sky. Okay, I'll swing some more. Taken in Iceland. Okay, recently. So now that remember, the one to the left and right is of course the clouds in the Earth's atmosphere. So basically, the clouds in the Earth's atmosphere are the most a few kilometers from the Earth's surface. But this aurora, the green object is very high. So usually aurora will appear from about 80 kilometers from the Earth's surface to even higher, above 100 kilometers. So the green aurora thing is very high up in the Earth's atmosphere. And if you define that space is 100 kilometers above the Earth's atmosphere, and above is called space. So some of these aurora can be above 100 km. That means it's in space, right? So this green aurora is very high in the Earth's atmosphere and in space, but the clouds is very close to the Earth's surface. But it's beautiful, all right? So this is it. And then here also, they talk about the famous Carrington event. Now, remember, we are now waiting that hopefully it would not happen. Of course, we want to see aurora, but please don't happen. That means in the history of solar observation, in the 1st and 2nd September of 1859, 150 years ago, there was the biggest geomagnetic storm ever occurred. That means on the sun's surface, there was a big solar flare, and they were thrown up those energetic solar wind particles that hit the Earth 17 hours later. Usually it take many days to reach the Earth from the sun, but 17 hours, less than a day, it hit the Earth, and there was a geomagnetic storm. And in this article, they will say that all over the world, that time, remember, 1879 was the age of the telegraph. So all over the world, the telegraph was affected. And it seems that some people handling the telegraph, what you call a station was electrocuted, there were sparks and so on. So we hope this Carrington event will not occur in our time, because they have said that if this Carrington event occurs, a powerful geomagnetic storm leaves the sun and hits the Earth, many things in the Earth will be affected. Communication, our internet will be knocked off, all right? The satellites will be affected. So now we are very worried of a big super Carrington event, all right? But this one was in 1859. You see the beautiful aurora very high up in the sky, and this is the Earth cloud, okay? By our Juan Carlos Casado, taken from this Iceland, okay? So now I pass over to Boon Wei, for the next
Oh,
picture.
hello. Yes, yes. Okay. Okay. Let me share my screen. Okay. Can you see my screen now?
Not yet. Yes, can see now.
Yeah. This is my first APOD to present. So this
Very
is the very very beautiful fireball meteor. Yeah. So this is, you can see these are the chemical grow as the title is the chemical grow as a meteor disintegrates. Yeah. So this is a meteor taken by Michael Kleinberger. He is a nature photographer from Austria. Yeah. So meteors can be colorful. He actually took this meteor in somehow mid of July using a camera. So only camera we can actually see. Sometimes our human eyes cannot see so many colors, but by the camera we can distinguish out take more colors from the meteor shower. So this is taken on the Hoka mountain in Austria, and he was doing the central band of the Milky Way photography. Then, very fortunate, the meteor come across inside the photo, and it could be the gradient drift likely to cast off from a comet or a asteroid long ago. It should be not any meteor shower recent in July. Yeah. So seeing from this picture, the meteor having more than three colors. You can see the red one, the green, then even the orange, the blue. Yeah. So normally the colors, right, can be analyzed. Yeah. So if we analyze the meteors color, then we could know what are the elements from this meteor. So basically, the blue green are from the magnesium, then maybe violet. Violet is from the calcium, and then nickel is a green color. So here got some red color is actually originates from the energized nitrogen and oxygen in the Earth atmospheric. So this bright meteoric fireball is actually gone in a flash, less than a second, but left a wind-blown ionization trail that remained visible for almost a minute. So I think can be wow and take your wish for a long time.
Yeah.
Yep. Okay, so I think coming meteor shower is the pursuit one. So hopefully can get another more photos like this.
And Boon Wei, get ready to make few hundred wishes that night.
Yeah, I already ready. Okay, so I will go to my next airport. Next airport is the Apollo 2 Armstrong Lunar selfie. Yeah, this is a selfie from Armstrong, our
Yeah.
first man step on the moon. Yeah, so this was actually captured in July 1969 while the Apollo 11 moon landing. Yeah. So actually, this image is the digital reverse image, processing by Michael Ranger. So the original photo is actually taken by Neil Armstrong. He took his his friend I think his colleague Buzz Aldrin, who standing on the moon, and then now the Michael, he actually use the digital photography method and then processing it lah, then making the making the original picture that from the agent curve visor. the helmet of the agent curve visor, and he the reflection of the agent curve visor, he go and process it, and then after some uh, reverse and then some distortion and then straighten. So the transform view is actually featured the Armstrong himself from the Adrian's perspective. So this is 44 years old Luna selfie.
Wow.
Yeah. So Adrian visor reflection in the original image is appears this the left one from the helmet one. And this is the Neil Armstrong, and then this is the this is the forward leg of the Eagle lander. And then you can see the uh, Adrian's long shadow
Yeah.
over here, and this one is planet Earth hang on the lunar sky. You can see still can see our Earth here.
Yeah.
Very cute. So
Yeah.
in 2024 next year, NASA Artemis 2 mission will return human to the moon again. So see maybe we can apply or not.
Yeah.
Okay, so I will go to the next one. So next one is the 19th of July. Chandrayaan 3 launched the moon. Yep. So this picture is taken by Shruti Suresh, space group. She is the master intern at Indian Institute of Astrophysics. So from this picture is the Indian Space Research Organization, and the LVM-3 rocket was just blast off from the Dhawan Space Center on Shaharikota Island.
Mm.
Yeah, India. So you can see this is launched on 14th of July at 2:35 p.m. IST. So actually choosing in the month of July for the launch of this Chandrayaan 3 was based on the calculation made by the ISRO regarding the closeness of Earth and the Moon. So this mission of this Chandra is to land on the Moon. Yeah. So LVM-3 it is a three-stage medium lift launch vehicle, and from the standing start, actually 600,000 kilograms of the rocket ship lifted the rocket off the Earth. So the Chandrayaan 3 is actually scheduled and expected to land near the lunar south pole region, is expected to land on 23rd of August, meaning next month, and then land a robotic rover. So this objective of this Chandrayaan mission is actually also to including to get a lander and then land safely and softly on the surface of the moon. And then they want to observe and demonstrate the rover's capabilities on the moon. And then also they want to collect some material on the moon. Yeah. So actually nowadays rockets bounce for space almost every few days from Earth. So many rockets launching nowadays. Uh yeah. Okay. So I'm going to my next one. My next one, and also my last APOD to present tonight, is a very fantastic picture, I think.
Ooh,
Yeah.
beautiful.
Yeah, very beautiful. Yeah, this is the picture on
Mm.
18th of July. Yeah, so you
Yeah.
can see this is they actually got many exciting features, and then you can see the star chart, and also with one, two, three, four telescope, the famous telescope here. So very very nice composite picture taken by the astrophotographer um, Marcin Rosadzinski. Yeah. So this picture is actually got uh, is taken on the La Palma Island in the Canary Island of Spa. Yep. So you can see from this picture, right? This one is the first the first telescope is magic, and then this is also magic one, magic two, and this telescope is a system of the two imaging atmospheric telescope. Is the sorry, the function of this magic is actually detect the particle showers released by the gamma rays using the Cherenkov radiation. Is it was the largest telescope with a diameter of 17 meters for the reflecting surface. Yeah. Okay, so the next one, this is a Galileo telescope. So is a Galileo National Telescope. Is also a 3.58-meter Italian telescope. So alta azimuthal reflecting telescope. So it is based on the Ritchie-Casson optical configuration uh, and a flat tertiary mirror feeding two opposite uh, Nasmith Foci telescope lah. So this is the optical telescope, and then another one is the Glen Canarian telescope, GTC. This is under a Spanish project, and is also one of the largest and most advanced optical and infrared telescope in the world now, because the light collecting for this telescope is up to 75.7 square meters. Very very then based on the collecting area, they can actually take a lot of information from the deep sky. So yeah. So the last one is the LST. The LSD name is a large size telescope. Basically, here all the telescope are large, helping us to explore all the ex- helping all helping us to discover the deep sky. So actually, come over like we have more advanced and advanced telescope, right? Helping us like in the past 100 years, we actually understand a lot ever before in all the human history. We actually studied a lot for the Big Bang Theory, everything. Yeah, because we are developing all the advanced telescope. So the LSD is actually also up azimuth telescope, and the surface of this is 23-meter diameter of the parabolic refractive surface. So mostly all the telescope have a very large surface, and then so that we can collect the one, and the refractive surface was about like 400 meter square to collect and also focus the Cherenkov light into the camera. So then it convert the light into electrical signal, and then analyze it. Yep. So these are the foreground, and then the background is the beautiful
Milky Way.
yeah, Milky Way. Yes.
Aiyo.
You can see this capture so many stars here. And it's called the constellation Scorpio, Sagittarius, Official, and some NGC. Yeah, very very nice composite picture. Yeah, and very informative from from this APOD as well. Yeah, that's all from me.
One more comment, Boon Bei. I
Uh,
really appreciate the astrophotographer. You saw or not? The Milky Way is pointing at the Grand Telescope Canarias.
oh,
So that means earlier the Milky Way was pointing in another direction. So he waited. The Milky Way will move. Just when the Milky Way is pointing down to the Grand Telescope Canarias, he took the picture.
yeah, lor.
Very
Wow.
nice, you know. So it's as if the Milky Way is going down, banging into the rooftop of that telescope lah, of the
Uh-huh.
observatory lah. Very
Yeah,
nice.
it's like coming up from the
Coming up from there.
from
Yeah.
there.
Mhm.
Yeah. Okay, so I will pass to Yunming.
Okay, thank you very much.
Sure.
Present. Present screen. Share. And yes, okay. Yes, my screen. Can my screen be seen now?
Yes, can see now. You mean?
Okay. So this is the first picture I'll be presenting for the July APOD, which is the July 17 APOD, which is shells and arcs around the star CW Leonis by European Space Agency, NASA, Hubble, Korean Astronomy and Space Institute, and Toshiya Uta. And the picture in general shows CW Lonis, which is a carbon star, and the surrounding waves in orange and red you can see around it. So what makes the picture special is that CW Leonis is the closest carbon star to Earth, and a carbon star is a star that has an atmosphere with more carbon than oxygen. The carbon star is not in the typical spectral class of stars of O, B, A, F, G, K, M. It's not in the typical spectral class, but it's rather a class C of carbon stars. Carbon stars such as CW Leonis tend to be luminous red giants, which means they have a low temperature, but their radius is, well, many times the radius of the sun. So in carbon stars, hydrogen is fused into helium, and helium is also fused into carbon in the triple alpha process to produce light and heat. And most of the radiation of this star, most of the spectrum is in the millimeter and submillimeter wavelength, means the wavelength of the light emitted is, well, it's measured in millimeters or fractions of millimeters. And what makes the waves quite important other than beautiful is that the waves expel carbon, which is needed for life to exist on the planet, because almost every form of life, as we know, is carbon based, including humans, animals, and plants. So how the planet gets carbon is quite important for how the planet gets life, and well, this is one of the sources of carbon for the planet. And of course, you wonder, how does the star expel carbon? It's because heat is produced when the fusion reactions take place, and there is a pressure pushing outwards as the gases expand due to high temperature. This force is usually counteracted by the force of gravity, but for carbon stars, they have low gravity, so carbon is expelled much easier, and other dust and particles, including the carbon, they might orbit the star and gather up, and they might form new planets billions of years from now. So I guess that will be what is interesting about this picture.
So that means, Yunming, the carbon in your body, in our bodies, and in all the living creatures on the earth, came from the earlier carbon stars that existed before our sun. So
Maybe.
that's how the carbon came in our body. Okay.
Yeah. And off to my next picture, which is a meteor in the Milky Way over the Alps.
Wow, wow, wow.
So, what makes this picture quite interesting, which is by Nicholas Roemelt, is that this picture is mostly luck. The the camera was set to capture meteors, but they were quite faint meteor meteoroids. Yeah, meteors. Yeah, there were quite faint meteors until it caught this very bright meteor in green by coincidence. And right, so this meteor is from the Perseids, which is formed when a group of meteoroids that's origin from that appear to come from the constellation Perseus enter the Earth's atmosphere as meteors, and if they survive and hit the ground, they become meteorites. And yeah, the Perseids is also the meteor shower that is occurring in the month of August that that we have previously mentioned in this APOD. So meteoroids are small asteroids which are bodies of rock or metals in space that is smaller than 1 meter. They have a diameter of less than 1 meter to be called meteoroids, and if it's larger, they're called asteroids. And meteor these meteoroids, they they follow the same orbit in the Perseid cloud. They form a cloud called the Perseid cloud, which follows the orbit of this short period comet, which is a comet that orbits and around the sun in less than 200 years, called the Swift Turtle. And as we can see in this picture, we can see the Milky Way. And the Milky Way appears as a band because the sun is in the Milky Way, and the Milky Way is to some extent a disk. So whenever we look in the direction of Milky Way, we'll see a line of or rather a band of stars and nebula in the plane of the disk, which is the Milky Way. And I suppose if we are lucky, we should be able to see the constellation Sagittarius, because Sagittarius is located quite near the Milky Way. And I think this also occurs and applies when looking at the Perseids. You should be able to see Sagittarius and the Milky Way at the same time.
When I saw Yunming, the way the guy is standing on the mountain top, I look so scared. You see, not much space to stand,
Yeah.
You must have climbed up there to stand. Not much space to stand there, the mountain top. Wow,
Yes. Yeah. The lights at the bottom also very nice lah.
very nice, yeah.
Okay, now on to my next picture, which is the July 15 picture of Webb's first deep field.
Wow.
And the image is taken by NASA, European Space Agency, Canadian Space Space Agency, and Webb's and near infrared ray camera. And so the first thing we can notice in this picture is that there are stars with a very sharp six the very sharp spikes in some of the stars, and we will notice very sharp spikes in 6 directions in the stars because the web is made out of 18 hexagonal mirrors arranged in a hexagon. So due to diffraction, we'll end up with 6 spikes for very near stars, such as the blue one in the picture. And And in this picture, we can also see clusters of galaxies. In fact, most of the blobs in these pictures are galaxies in galaxy clusters. And if we look at some of the pictures, we notice that there are some curves, and this is due to gravitational lensing, where the gravity of a very massive object, in this case, the galaxy cluster, can bend the pathway of the light, and in this case, it acts to magnify the light. Without the galaxy cluster, we will see a smaller picture of the galaxy. And actually, anything with high mass and high gravity can act as a lens and bend light, such as a black hole. But in the case of a black hole, light is bent completely and does not escape the black hole after a certain radius. So we might wonder, how does each line or blob here appears to be the same galaxy or two different galaxies? Well, the spectrum of light, the light is collected from these two objects, and they're compared. And if the spectrum of light intensities of chemical composition appears to be the same, then scientists know that the two images are mirror images of the one same galaxy. And this is again one of the very nice pictures the James Webb Telescope has taken since it was launched last year, or is it 2 years ago? Very nice picture with lots of stars. Yep. And on to my next picture. This is my next and final picture, which is the July 14 picture that shows comet C 2023 by Dan Bartlett. So the focus of the picture is the very bright comet in green, and there's a faint ion tail that is going in this direction. And comets are dust or ice that orbits the sun in very elliptical orbits. The orbits are not circular, they are quite stretched out ovals or ellipses. And comet C 2023 is a comet that's periodic. In fact, it's a short periodic comet of 85 years. So what this means is that the comet is on a bounded orbit. That means we at Earth will be able to see the comets over and over again every 85 years. And well, the comet is the orbit is quite ecliptic, which is a very stretched circle. And now, what makes the tail of the comet? Now, as the comet goes past the sun, part of it melts and evaporates. Part of the dust and gas evaporate, and the dust and gas that's evaporated, they form a coma, which is the very bright green ring we see around the central body of the comet. And when the comet orbits the sun, solar winds push on the comet and on the dust and particles of the comet and push it away from the sun. So the dust tail, which is not visible in this picture, usually points away from the sun. And this phenomenon occurs, the tail of the comet pointing away from the sun, throughout the whole time the comet is orbiting the sun. And this particular tail, which we see over here, is the ion tail, which is formed when ultraviolet rays from the sun interacts with the comet, and electrons are expelled from particles in the comet. And well, after there are electrons emitted from the particles, ions are formed, And these ions, after they are formed, they form cluster, which induce a magnetosphere. And of course, what is a magnetosphere? A magnetosphere is a sphere around a body, a celestial body in space that prevents a very high magnetic force influence. In fact, the auroras mentioned by Dr. Zhong earlier on, those are caused by the magnetosphere of the Earth interacting with solar wind particles. So likewise, the comet has a magnetosphere which interacts with solar wind particles, and charged particles move away from the comet. They are blown away from the comet by solar wind particles in this direction. So we can roughly tell the comet is going somewhere in this direction. And again, this is a very beautiful comet that we will be able to see once every 85 years. And that will be it for my last picture, and I'll be passing it on to Dr. Chong.
Thank you, Yun Ming. Okay. So I share my screen. So next one is 13th of July. I'll show the big picture first. Yeah. Okay. Webb's row Ophiuchi. Remember Ophiuchus constellation? You have a lot of those dust cloud, beautiful one. Okay. Of course, taken by our, if you see here, Webb's exploration by James Webb. And again, earlier, like what Yuning said, you have actually many diffraction spikes. You have the 6 main ones here because of the fact they have so many of the hexagonal segments joined together. And you give the diffraction spike. And then there's another 2 over here. 2 over here. And you see, this one is double, you know. Here got double line. So here, another 4 here, due to the fact that the secondary mirror of Webb is held by 3 what you call struts, 3 of metallic rod holding it. So it will give another 2 spike here and another 2 spike. So actually, many spike. So get ready in future. Whenever you see any S1 picture, got 6 big spike. Webb. Hubble is only got 4 spikes. This one got 6. Okay. So here is by our NASA, by European Space Agency, Canadian Space Agency, and Space Telescope Science Institute. So Junming and Bunbei, so nice if you all can work in Space Telescope Science Institute at the Johns Hopkins University in Baltimore, Maryland, near to Washington, D.C. Because why? This institute now is in charge of 2 telescopes. Hubble still working and Webb.
Oh,
And
wow.
so the scientists there must be very busy. Okay. And of course, from this staff in working Klaus Pontopidan and processing by Alicia Pagan also in the institute. All right. So you should be very what you call busy. So I shrink the picture first. You look at it, so nice. All right. And look at the detail. Remember the pictures in infrared. So basically, the power of this Hubble is infrared, and infrared wavelength, electromagnetic wavelength, can penetrate through the glass cloud, can see behind the glass cloud, the dust cloud. Whereas the Hubble using visible light cannot see behind the dust cloud because the dust cloud will absorb the light. But this one you can see through, and then of course because it's infrared, you can see through the dust cloud and can see further into space. So basically, the James Webb can see closer to the Big Bang, but unfortunately, Webb cannot see the Big Bang. We hope for in future they will have a telescope so powerful they can see the Big Bang itself, the moment of creation of the universe, but they cannot. But at least they can see further than Hubble. All right, and this is it. And this is look at the spikes here, and this is our real Ophiuchi dust cloud, and you can see here the details here. So it's like that, you know. Sometimes there's a very important picture. For example, I think many of the pictures by Webb should be very important. Maybe you have a young girl astronomer somewhere in America or Japan. They spend 3 years to work on this picture, and after that, what? PhD lah. A PhD on a certain aspect of this real Ophiuchi dust cloud. All right. So I go to the next one. July 11. You saw that? So basically, here is by NASA, what you call Solar Dynamics Observatory, the most powerful telescope by NASA studying the sun now. And the processing is, of course, by Seno Sanli, a Turkish amateur astronomer. So these people, Seno Sanli, are what they call citizen scientists. They are not paid by NASA and so on, but NASA got so much work to do, no chance to process. They sent to this Turkish astronomer and he will process it. So basically, he took from the beginning of this year, 1st of January, to the end of June, all right, all the days that you have sunspot on the sun, they added up. So these are all the sunspot on the sun for the first half of this year. Look, so many sunspots. Remember, we have not reached the solar maximum yet, Solar maximum for cycle number 25 will be in sometime in the middle of 2025. It will be even more. And now you see that more and more of the sunspots are migrating towards the solar equator. So initially, in the beginning of the year, most of the sunspots closer to the not solar magnetic pole of the sun and the subsolar magnetic pole. But now more and more coming closer to the equator. So this is a beautiful sunspot for the 6 months of this year. All right, taken by the Solar Dynamics Observatory, and this is taken in what? Visible light. In visible light. We go to the next one, 9th of July. Very nice. And by NASA, European Space Agency, Hubble Space Telescope, and processing by our famous Judy Smith. Now, Judy Smith is actually another citizen scientist. She's staying in this California. She's not a NASA staff or scientist, but she can know how to do a lot of processing by her. So this is our famous nebula in Eta Carina, in the constellation of Carina. And this one, since in the middle of the 19th century, astronomers have been waiting for what? For this star to go bonkers. Why? Supernova. But unfortunately, even in the middle of the 19th century, it not to say blew up, it became very bright, not a supernova, very bright, and you can see both of these lobes expanding. Sometimes they call this what you call homunculus nebula. All right. So we hope that this one will become a supernova one day. And now you saw not 4 spikes, that means by Hubble, 4 spikes is by Hubble. All right. So this is a star which one day, hopefully not too long in future, will become a supernova. When? It can be tomorrow night, or it could be a million years from now. Because predicting when a star will become a supernova, when a star will become a nova, is still very unpredictable. Just like on the Earth, very hard to predict an earthquake occurring in any place on the world. You can give a probability that in this place in Japan, there will be a magnitude 7 earthquake in the next 50 years. But you cannot say exactly this part in the world when a big earthquake will occur and what magnitude. So it's very hard to predict when this star will become a supernova, but they are waiting. Okay, the star Eta Carina. Why is it called the doom star? Because they know it's going to die one day, become the supernova, because it's 100 solar masses. 100 solar masses is much bigger than the Chandrasekhar limit. Once the Chandrasekhar limit is about 1.5 times the mass of the sun, it can become a supernova. But this is 100 times the mass of the sun. So it can become a supernova, and taken by our Hubble. All right, very nice. So the next one is on the 8th of July. I like this. Okay, so you don't mind me saying so. Yunling, I told many of our USM students, the boy students, that you look at the history of astronomy. Now this is what Stickney crater, a crater on one of the moon of Mars called Phobos, and this is named after a woman called Stickney. Okay, so basically, Stickney is the wife of Asaph Hall. Asaph Hall is the American astronomer in the 19th century who used his telescope in America to discover that, hey, Mars got two moons, and then in one of the NASA mission, all right, passed by the Mars earlier, all right, and took a picture of this of the moon, and they saw that there's a crater, all right. So actually, this crater was also given by the scientist, called Stickney crater. Now, Stickney is actually the wife of Asaph Hall. the discoverer of Phobos. That's why I told my USM student that actually, if you want to be famous in astronomy, you need not say have a telescope to discover the comet. So let's say if one of the astronomers in Malaysia got a girlfriend, and this astronomer in Malaysia discovered some object. In this case, let's say a moon around an object, and on the moon there is a crater, and this boy's girlfriend has a name. It's called Stickney. So you can become famous without making the discovery, but because you are the girlfriend or wife of that astronomer, they'll give you the name. So this Stickney, and it seems that this crater is about close to the half the size of Phobos. Now I think Phobos is about around 10 kilometers in diameter. So this is very big, half. They say that if the object that hit this moon Phobos years ago, a bit more powerful, they will have broken up this moon of Mars. The small moon Phobos, and with this crater there, and you look at the detail, right? So the detail is exposed material of the of this Phobos moon. All right, very interesting. Okay, so this is taken by our high-rise camera of the Mars Reconnaissance Orbiter. They're still orbiting Mars, and this famous laboratory, in University of Arizona Lunar and Planetary Laboratory, okay, by NASA. So this is very interesting. So now we go to the next one. 7th of July. Okay, double cluster in Perseus. Okay, Perseus is a constellation in the northern sky. This is a double cluster. This is one cluster and cluster. You've seen many times in our Lim Chun Kiat Observatory in Bali Pulau. Very nice, can see. And some people say that if you are in a very dark location, you can see this double cluster in Perseus with your naked eye. So they even have a name here. You have here the H and Chi Persei. So H Persei is this cluster, and Chi Persei, these two Greek letter, Chi Persei is of course also in Persei. So these are two open cluster in Perseus constellation, and they also have NGC number. NGC on the top one is NGC 869, and the one below is NGC 884. 869, 884, NGC. NGC is a wrong name because NGC started in, I think, the 19th century. It's no more. NGC means New General Catalogue. There's nothing new of it. It's more than 100 years old, but they still use the old name, New General Catalogue number. All right. The double cluster in Perseus constellation. We go to the next one. 6th of July. I really like this. Wow. Yo. Wow, what is this psychedelic picture? No, this is a photograph. So it's taken here, you look below here, by Michael Sealer. So Michael Sealer here is actually a health executive. That means maybe he belongs to a certain company due to health issue. And he's not an astronomer, but he actually, he calls himself a space nerd. Anything about space exploration, he will be interested. For example, this is taken from Cocoa Beach. Remember, Cocoa Beach is a beach outside Cape Kennedy Space Center in Florida, where they launched many of the missions, the NASA mission. So he was there, and there was a 4th of July, because for the Americans, 4th of July is their national day, their Merdeka Day, and there was a fireworks there. And just at the same time, the moon was there, and the fireworks was between him and the moon. So he took it. So it's called fireworks versus supermoon. So at the same time, the moon was very close to the Earth, perigee was big. So it's a supermoon. All right. So this is the fireworks and the supermoon by our space nerd, Mr. Michael Sealy. All right. The 5th of July, the next one. This is actually very fun. I can spend hours on this. So this one is a map of the observable universe by our Bryce Maynard. Okay, Bryce Maynard is actually from the Johns Hopkins University, all right, Baltimore, Maryland, very near to the Space Telescope Science Institute. And Nikita Startman is actually a 3D designer, also from America. So basically, they took all the pictures by SDSS, Sloan Digital Sky Survey. Remember, years ago in America, there's a very big optical observatory on the ground. They actually look at hundreds of thousands of galaxies, find their location, and also get a spectrum. And from the shift in the absorption line in the spectrum, they know the what we call recession velocity. And applying the recession velocity to the Hubble's law, they know how far is the object. From the shift in the absorption line of each galaxy, they know how far is the galaxy. So here, our Earth is here at the bottom here, and here every single point is a galaxy, you know. Every single point here is a galaxy. And as you go further and further away, the redshift become more and more and far. And you see what's at the end here, I try to enlarge so that you all can see. I would say, sorry, maybe I have to send a reminder to these two guys. They made a mistake now. 13.7 billion years. Actually, now, the data by James Webb is coming in that they have to revise this. It seems the age of the universe now, the more accurate estimate is 13.82, or at least 13.8 billion light years, increased by another 0.1 billion years. I mean, 100 million years further away, right? But never mind, you use it at, so this 13.7 billion years old, the universe, or 13.7 billion light years from the Earth, is what they use in the textbook. But now it should be 13.8. So basically, you have here, this is a cosmological map of all those galaxies from the Earth to the edge of the universe. So as here basically are galaxy, and then as you go further away, you have the great redshift better, and as you pull right to the end here, you have the point. They are the quasars. Quasars are what? The quasi-stellar object. That means that they're actually supermassive black hole where the matter is going around it and falling in and giving you a lot of energy in the form of visible light or X-ray. So these are all quasars at the edge of the universe. So remember, each point is a galaxy or a quasar, no? So how many galaxies are here? So this is only one slice, you know. At the bottom here, there should be another slice. But sorry, guys, the space to the right here is black, nothing, and the space here is black, nothing. It's called the zone of avoidance. What do you mean by that? Because you see, this one is, if we are at the location of our Earth is orbiting the sun, and our sun is located in the Orion arm of one of the spiral arms in the Milky Way. So if you look perpendicularly northwards, you see this. There are no dust cloud blocking the light. All right. Below also there's another slice there. No dust cloud or blocking the light. But here to the right and the left, you're looking at what here? You're looking at the center of the Milky Way, a lot of dust cloud. So you cannot get the object, the galaxy, billions of light years away from Earth, passing through the dust cloud. So here we don't see anything. Here also we don't see anything. But here you can see. Okay. So this is a very beautiful picture. Okay. A map of the observable universe. Okay. But still, in a sense, this is not complete because this is what? Invisible light. All right. In UV light, invisible light, in infrared light. They're not talking about radio universe, you know. So you can have another map of the universe called radio map of the universe, because radio wave can penetrate through the dust cloud, no problem. So the radio astronomy map will be even more fantastic. All right. So this is a visible light, a map of the observable universe. Okay. So now we go to the next one, July the 4th. Another aurora, Yun Ming. So this is another aurora. Very nice. Okay. I read first. It's taken by our Charlie Letelier. Okay. Charlie Letelier is an amateur astronomer from Chile that traveled all the way to the Iceland and took this picture. All right. So it's aurora. All right. With the above a waterfall. And the waterfall got name, you know. It's called our Godafoss waterfall. All right. So again, I would say, let's go to a smaller picture now. Reduce it. Reduce some more. Okay. So you have basically like what William said earlier, I add on. Basically, we have those solar particles, solar wind, which are what? The electrons, the bare electrons, and the ions, IONS, like the protons, and maybe some of the lighter element strip of the electron emitted by the sun. and traveling towards the Earth at a fast speed. And they are, as they approach the Earth, they hit the Earth's magnetosphere, right? And the Earth's magnetosphere is such that they will channel those solar wind particles when they approach the Earth's equator to go towards the North Pole or to go towards the South Pole, right? Because you have to apply a certain law called the Lorentz force law. So if you have a magnetic field line like that, you have an electron passing like that, perpendicular, this magnetic field line is blocking it. But if a magnetic field line is like that, then magnetic field line of the Earth, the magnetic field lines of the Earth is not only appearing on the Earth's surface, it appears thousands of kilometers into the atmosphere, away from the Earth's atmosphere, into space from the Earth. So as you have the magnetic field line, and then you have the electron and the ion from the sun, it enters a certain angle. The magnetic field will channel those ion particles into the north polar region and the south polar regions. And these particles, charged particles, when they hit those N molecules, which is what? Oxygen and nitrogen. So imagine you have a certain electron, you knock at one of the oxygen in the upper atmosphere. So the electrons, the orbiting the nucleus of that oxygen atom or molecule will be kicked out. And that oxygen molecule or atom will be excited. But then it will be excited for a short moment only. Later on, it will de-excite, meaning that now you have a oxygen atom or molecule lost an electron. Very quickly, another electron somewhere else will fill up the space that is left empty by the earlier electron that was kicked out. So when the electron from outside filling the gap again, then it will emit a photon. So usually in the aurora, the green is actually from the oxygen molecule, and the red and the pink and the purple is from the nitrogen molecules. So you see the oxygen molecules there. And as I said, this is very high, can be 100 kilometers from the Earth's surface or higher. Okay. And a beautiful one here is the moon. Now, some of you may say, I thought this is the sun. Look carefully again. This has to be the moon. Why? Why? Look carefully. The author didn't explain why. You can see the stars here shining through the aurora, the stars here. Okay. How can you see the stars in the sky with the bright sun? Cannot. So this is the moon. It's possible to see the stars in the sky when there's a bright moon. So that's possible. So this is taken by Kerry Letelier from Chile in in Iceland. Very nice. So again, he actually said like that. A group of astrophotographers went to Iceland, waited at this place, waited and waited and waited. Cloudy, waited and waited. Most of them left already, but Kerry Letelier was lucky. He got extra patient. He waited a bit longer. Suddenly the sky cleared. So it's like that one, you can see many of the beautiful astrophotographs, or even the famous discovery in astronomy, where the astronomer said, I got previously was like using the film, he got an extra film in the camera many years ago in the film photography era. He got one more extra unexposed frame. So he waited and he took it and he made the discovery with the last frame. Or waited the whole night, sky was no good, and suddenly it opened up for half an hour and he made the discovery. So this guy was lucky, all right? Kerry Letelier from Chile, who went to Iceland to take the picture of the aurora. Okay, so we see the next picture, my last picture, 3rd of July. This is really fantastic. Okay, Venus in ultraviolet from Akatsuki. Akatsuki, we follow already, is a Japanese space probe sent by Japan to orbit around Venus. Right, it's already orbiting around Venus for some years already. So this is by JAXA. JAXA is a Japan Aerospace Exploration Agency. So JAXA is the Japanese NASA, and the team that took this picture with the telescope is Planet Seed Project team. And this is a head tip to Mehmet Hakan Ozarak. Okay, now remember there are many citizen scientists, So Mehmet Hakan Ozarak is a medical doctor in Turkey. All right, and he actually has processed a lot of pictures by NASA and so on. So HT means head tip. That means you take out the head and say, terima kasih, thank you for processing for us. Our Dr. Mehmet Hakan Ozarak from Turkey processed it, the raw file, but the picture is taken from Akatsuki space probe from Japan that is orbiting around Venus. And you see here, so much detail here. And here they are taking a lot of pictures in ultraviolet also, right? So a lot of detail. So again, if you look at this picture, there's a team of Japanese scientists working on this data, no? Not only a team of Japanese scientists, master student, PhD student. Maybe by studying this sequence of picture, can get PhD lah. So let's say you get a PhD. So what? Maybe there's a Japanese student say, I'm okay. What PhD are doing? I'm doing I'm studying specializing on Venus. Okay, and I'm studying the climate of Venus, climatology of Venus. Okay, very nice detail. Of course, it's impossible for us to see visible light to the actual surface of Venus. This is actually the cloud tops of Venus, because the thick clouds which made of water vapor, carbon dioxide, will block the light from below. But remember, years ago in the 1990s, Galileo, not Professor Galileo, the human being, the space probe, NASA sent a space probe called Galileo mission, orbit around Venus, and fire through the thick atmosphere radar wave, long wavelength electromagnetic wave, just like your police sticks have radar wave. So the radar wave will penetrate through the clouds of Venus and bounce back to the what it calls the space probe orbiting around Venus, and they were able to map the surface features of Venus, the Magellan, a lot of volcanoes, you know. So that's the famous Magellan pictures. The mission is called Magellan, orbiting around Venus years ago, but that was in using radar. You can actually see the many surface features of Venus, but this is invisible light, so you cannot see. So you can see the cloud tops of Venus, but a lot of data about Venus from our Japanese space probe, Akatsuki. Okay, so I think that's my last picture. I stop sharing now. So Yunming and Bunbei, any comments from you all?
No.
Comment.
Yeah.
No comment.
This month got many aurora photo.
Yeah, more will be coming. So you know now, many people, remember we did our posting that we hope in the 1991, 1992, Hunwei and Yunming, I was already subscribing to Sky and Telescope magazine for some years. There's one Singaporean amateur astronomer using his camera, film camera. He was able to capture aurora in Singapore. Not with your eye, it was very faint, but with the camera, long exposure. So we hope that, like the Carrington event, 1859, 1st, 2nd September, they saw this event where all the telegraph station all caught fire, and the geometric storm was global storm. So we hope okay. So in that case, you have a big event like that, you may even can see with your naked eye aurora in northern Thailand, in Hong Kong, or maybe you can see in Jakarta. All right, no need to go to the North and South Pole. You can still see. We hope for a big event, the aurora, okay, powerful aurora caused by a big solar flare from the sun. Okay. Anything else? Okay. So I would like to end. So our big event, Yunming and Bunbei, is Pacific, 12th of August, 13th of August, which is on a Saturday and Sunday. So we know first day, because of the fact that of the voting, we cannot go anywhere. We have to go for voting. So we've been Penang. So we're going to make announcement now. So I'll check with our member Chun Kiat. Yunming, you're always welcome to join us also. That Lim Chun Kiat observatory in Bali Pulau to see the Perseid. And if the first night was good, we shouted 100 times, 200 times for make wishes. Second night got a second chance. So most important for the Perseid is good weather. But don't worry, no moon. It'll be old moon. So the moon will not be there until very much later, closer to the sunrise. So 12th, 13th of August, Perseid meteor shower in Penang, we are going to observe. Okay, So thank you everyone for your patience for watching. All right. So we wait for the next coming APOD presentation in the end of August. Okay, So thank you to everyone. Okay.
Thank you.
Thank you.
So Michael will take us off from the internet. We can still discuss if you want.